this module, we will examine the use of timber systems in the construction of lift shafts. In this presentation, we will cover the different lift shaft construction options, the NCC requirements for sound and fire, and some usable transition construction details for lift landing doors and sills in mid-rise timber buildings. Timber buildings can utilise full timber lift shafts protected by fire-rated linings, or a hybrid approach, and incorporate concrete or masonry shafts. If a hybrid approach is adopted, it is important that the potential for differential movement between the timber structure and the non-timber shaft is taken into account when detailing connections and interfaces. When designing lift shafts, it is also highly beneficial to involve the lift supplier at an early stage to ensure the shaft will satisfy their design requirements and applicable regulations. In terms of the acoustic requirements for timber lift shafts, the NCC airborne sound requirement for walls is an RW greater than or equal to 50. The NCC Part F5, Clause F5.5 also stipulates that a wall between a sole occupancy unit and a lift shaft must be of discontinuous construction. This means two separate leaves with a minimum 20mm gap, as shown here. The NCC requirements for floors are, for airborne sound, an RW plus CTR greater than or equal to 50, and for impact sound, an LNW less than or equal to 62. The NCC fire requirements applicable to general lightweight timber framed lift shafts in mid-rise timber buildings are as follows. For Class 2 and 3 residential buildings, for load-bearing walls, an FRL of 90-90-90, and for non-load-bearing walls, -90-90. For mid-rise office buildings of 4 stories and above, the FRL required is of 120-120-120 for load-bearing walls, and -120-120 for non-load-bearing walls. For all these 3 classes, an RISF value is also required of 45 minutes, and for the lift landing doors, an FRL is required of -60-. For massive timber-framed lift shafts, the NCC fire requirements are similar to the general requirements for lightweight construction. However, the MRISF values are different, with a 30-minute requirement on the outside face of the shaft and a 20-minute requirement on the inside face, which reflects the lower probabilities of severe fires occurring in these areas. This slide illustrates the requirements for a massive timber-framed lift shaft. You can see the MRISF requirement of 30 on the outer face, shown in red for an external fire, and 20 minutes on the inside face of the shaft, shown in grey for an internal fire. Most lift landing door assemblies available in the short term will have been fire tested in masonry, concrete, or steel stud shaft wall systems. Accordingly, until further fire testing is undertaken with fire-protected timber systems, the following transition details provide an accepted interface between fire-protected timber and a precast concrete sill and steel shaft wall systems. In the longer term, it is expected that a larger range of lift landing doors will be fire tested in fire-protected timber construction, providing simpler installation details. In this slide, we can see on the left an elevation of the lift shaft over 2 floors and the lift landing and door assembly. On the right are 2 sections through the fire-protected timber walls. The upper section through a general timber double skin wall, and the lower section through a fire-protected massive timber wall. Note in both these sections no timber is exposed. All timber is covered with the required layers of fire-grade plasterboard to achieve the required FRL and RISF or MRISF. In this slide, section BB illustrates the requirement for utilising a precast concrete sill. It can be seen that the floor-ceiling system is protected by the fire-rated plasterboard horizontally, but that the precast concrete sill has been used to close off the cavity vertically. So in summary, lift shafts in mid-rise timber buildings can be either fully timber, protected by fire-rated linings, or a hybrid, incorporating concrete or masonry. NCC sound requirements for timber lift shaft walls is an airborne requirement RW greater than or equal to 50. And for floors, an airborne requirement RW plus CTR greater than or equal to 50, and an impact requirement LNW less than or equal to 62. Common walls between lift shafts and SOUs need to be of discontinuous construction, using 2 leaves and a minimum of 20mm gap. NCC fire requirements for FRL, RISF, MRISF for lift shafts are specified and need to be met. And finally, appropriate details for the interface between the fire-protected timber and a precast concrete sill and steel shaft wall systems are available in the interim until more specific testing is done in the future. For further information on wood and wood products, visit woodsolutions.com.au, the website for wood.